This video is an actual survey. We're going to survey one or two poles. The start pole is always the most difficult. We laid out quickly three poles, and we're going to start at pole number 2 and go to 3. As you can see, we've got a couple of geometry circles. They're offsets from the road center lines to place the position of our pole. We could use GPS to place the pole, but in this case we're using imagery. So I'm just going to take these two devices off our tripod and head over to the pole. Bit of traffic, so we might have to stop for that. So it's a joint use pole, and you can see there's a few anchors. We got a anchor for our comm line, which is Bell, and then another anchor for our secondary, and then 2 primary anchors. So we're going to put those on first, which are not, we're only positioning them to start. There's actually 3 separate anchors and 4 down guys, but we're going to place the number of anchors to correspond with the actual physical anchors. So we've got 3 anchors laid down, and right now they're all on top of each other because we haven't defined their lead lengths or their ownership. So you'll see them change once we've populated the internal attributes. Next, let's take pictures or photos of the pole. We're looking north, so we're going to go to the photos page. Here's our north shot. While we're panning around, we could get a power shot of, say, the whole power. And maybe a close-up of the secondary. And then we'll get our east shot, looking east. And we can get a west shot. Let's just get one more power shot because this looks like a good clear view. Get our comm shot. And this is a good location to actually get the comm cables, because you can see the cable going into the telco splice is the same thickness as it is coming down the pole. We can measure it, the thickness at the pole. So next, let's get some close-up photos of our tags. There's a whole bunch of tags here. We can get them in one shot or split them up into different photos depending on what tags they're for. And here's our stamp. And let's just take a peek to see if there's any ownership nails. If it's owned by Bell, they almost always have their own ownership nails. And if it's owned by, in Ontario, it's Ontario Hydro One is the power supplier once you're outside of some of the towns, and they don't always put on nails, and it doesn't look like they have on this pole. So now we'll go to populating the pole. The owner tag. If you tap the yellow label, the photo pops up so that we can easily copy what's down there on the photo. Let's see what else we have. Then here's our address. We already looked up ahead, and that is the correct address, but the maps database supplied that as a suggestion, and they were right, as they usually are. It's a wood pole. Pop up our class information, and we can see that it's a 60-footer. And it is owned by Hydro One in this case. And we have a 3 class. and it is joint use. There's a little bit more information. The species is RP, and it looks like preserve is P. And it looks like 81, but we don't know. We can't see it exactly for the year, so we'll leave that out. Let's go to our pole dips. And we see there's two.
Nothing I need to be made aware of, sir?
No, we're just surveying the poles. We're surveying the poles.
Okay.
And
I just wondered if I had to.
no,
I saw the sweaters and I'm like,
right.
I saw sweaters in my yard.
No, it's actually for a training video for an application.
Sorry?
I'm actually doing a video for a training video for the application of surveying poles.
Okay. No problem.
Okay, thanks. That might get scrapped, but so we have two down service drops, power service drops we're going to put on the dip section. And so you can grab those from the power pull-out. The one-time service drop, you get two of them there, add one more. And then there's also a power vertical ground right here. If you need those for your survey, you can add them. You can even go into detail and define that it is a conduit, and it's a 2-inch conduit. Same with the other one. Next, we'll do our comm, and we will add a comm line, and you'll see nothing until you've actually physically placed the comm. And you can learn the details of how to place every different attachment and element in the different videos that cover more detailed. But for here, we're just going to quickly go through and survey as if it was a real survey. So our ownership here is Bell. And if we look closely, we can see it is a 3/8 thickness strand. There's one cable, and it looks to be an inch copper. You can either define your cables by twisted pair count or by thickness. The line is anchored, and is it grounded? I think yes, it is bonded to the power vertical bond. And then that's it for the comm line. Then we add there's another comm line above. It looks like it's probably a Rogers comm line. And I can see that's a 1/4 inch. It's really thin. And they've got one tiny distribution coax cable. It looks like a 500 cable. I'm gonna add the cable. One thing I forgot is that Bell has a fairly heavy element there, a large telco splice. So if your engineering team requires weight objects, you might want to add the copper splice on that line. And then your Rogers is not anchored because it carries on straight through, and it's on the back of the pole. That's where we place it. The next line up would be a power line, which is a streetlight cable, and then we also have a spun bus above that. Let's add a power line for that. And then we have a cross arm, and we have a set of primary insulators above that. So I just laid out the base for all your attachments. And then let's look up at the lowest. Come over here so you can see the with the sky behind it better. The lowest power line goes to the west. So we'll add that, and it hits the center of the pole. So it's a two wire street light cable. And the streetlight cables are usually the lowest denominator of neutral gauge. It's braided, and then we'll save. Next line is going the exact opposite way to the east, center located also. But that is a 3/0. That's a 3 cable spun bus 3/0, and it's braided, it's not lashed, which is important for a lot of engineering because different requirements are set for whether it's lashed or not. On the opposite side, we have, at the exact same attachment height, we have a neutral. So we choose opposite, and then we touch that line because everything we change here will affect all of the lines unless you select an individual line. So we'll change that to a neutral. And it is a lesser size. It is a 1/0. So because the spun bus is heavier gauge and more cables, it is anchored in this case. So we checked anchored, and it also dips. And both lines are bonded, so we deselect that line and then hit bonded to bond both of them. Save. Now we move into the crossarm. Crossarm has been automatically placed in the opposite position that we want, so we hold the screen, and by default it switches it to the exact opposite position. Except it is a metal one. Let's add our lines to it. We have 3. And if you pull in the direction of where there are more than one line, then it places the extra line on that side. Then you can hit the other direction, and from the pop-down menu, the through option is usually the one you would choose. Now let's scroll up. You can see all the lines are in the dead end position. We're going to change those to through because they have insulators. And that's all. We need to assign the conductor gauge. I'm going to pull out my binoculars, my rangefinder, and I see that they are a 336 gauge. And I'm going to save it. Then we have the insulators, which is a simple combination of a tier and top. You could change the top position if you wanted to, but it was actually set correctly. Then you could go into the individual tiers and assign their gauge. And I believe this is, I'm looking through my rangefinder, is it the same thickness as the lower? They look to be, and I actually think those are probably 556s, not 336s. So we're going to change the other attachment we did. So we go into each tier and we change it to 556, save. And the top line, sometimes you have to double save that. We'll go back into the crossarm and let's change globally the gauge to 556 and save. Now you'll notice there's green check marks all across the attachments. That's because all of the attributes, all of the required attributes that we have defined in our quality control settings, the conditions have been met. We've filled out all the attributes that are required, except for the anchors. So those, I'm not actually going to measure them all for this video. I might just arbitrarily make up some distances, but let's go into the anchor attachment. And as you can see, our anchors here, they look to be on the same vertical level where they hit the ground as the base of the pole. So we don't need to add a vertical height adjustment. The first anchor is a single anchor. And if you try and pull up the guard, we can see down here we have a triple I, and it's a single piece. I think it's a single piece. No, it's a double piece. And we can't see the thickness of the rod because of the earth. So we will get the anchor view out of the way, and we'll we'll choose the triple, double piece, and then we'll click is concealed by the earth. The gauge of the guy is 3/8, and the first guy here is for the com, which is bell, and then we're going to get a lead. In this case, I'm going to use my laser, and I get 4.9. The rest of them I'm going to arbitrarily guess. So then we can skip to our next anchor, and that's a single one as well, and the next anchor is a double. So let's go back to the first unpopulated anchor, and that was for the spun bus. Oops, I hit com. It's for the spun bus, or the secondary you could put, and it is also 3/8, and I'm going to guess at the rest of it. And the next one is, they're both primaries, 3/8 I'm guessing, and let's say a twin 2-piece 7/8 rod, and we'll say the lead is 10, and we forgot the lead on this one. Let's say it's 5.2, and I think that's all of the values required. Yep, we got a green on the anchor, and as you can see in the drawing, that the anchors are now spaced out and they're color coordinated. So we will save the pole. It's still red, and we just need to shoot the attachment heights to make that go green as well. So we'll go over and place on our tripod, and we're gonna have to get heights for our 2 dips as well. So go into the height routine, shoot our pole. Normally I place a baseline, but for the video I forgot to, so we're going to go right to the base of the pole, and we're going to go into the app here and erase the 1.5 meter mark for our baseline, because I'm going to the actual base of the pole. And now I'm shooting this dip, the top of the dip. They need to know where that is. It's at 7.4. I can't see the other one from here, so we're going to guess it's the same for this video. 7.4. Then we're going to go to the bell line, and 5.55. That would mean that the anchor for the bell is also 5.55. While we're in the anchors, we might as well finish them. And we have a spun bus anchor measurement of 8.1. And the 2 primaries are 13.4 and 14.3. 13.4 and 14.3. The anchors, as you can see, are now green, so is the bell. Now let's go to the Rogers, which goes straight on through on the back side of the pole, 7.2. Streetlight cable is, oops, wrong position there, 7.95. The spun bus and neutral are at 8.25. And we forgot the drip loop height of those is at 7.1. Now, anything that has a drip loop field will show that 7.1. That is the lowest position for our power. Next, we have our cross arm height is 10.35. And our insulator height, I know by fact that that particular insulator is 0.35 meters between the center of the cross arm and the line where it carries. So we can type in 0.35 either into the insulator height, or you could have entered the line height if you prefer to do that. Next we have the lower insulator, 1375. To exit, go into the lowest tier insulator. 13.75 is the lower bottom bolt height. The other values are calculated based on the spacing of the bolts in your settings, your op settings, and the line height. If they're different in the real life situation, you can adjust them here, or you can change the entire spacing in your settings. Then we have a top of pole height of 14.7. And then the last height is the top insulator height, which is about 0.55, I think. But I'm measuring the line here, so 15.27. Oops, I did 16. 15.27. And we exit, we save, the whole pole is green. And now we're ready to do the next pole, which is going to be way easier because it's half populated. All the attributes are already there on all of the line attachments. And it is a simpler pole. So your first pole takes most of the work, and then from there it just gets really easy. And